Okay. Hello everyone. Very good evening. I welcome you all at India's most comprehensive preparation platform for all competitive exams, that is BYJU'S exam prep. So guys, today we are going to discuss another classification algorithm. Last time in the last session we discussed one classification algorithm, that is known as k nearest neighbor. Today we are going to discuss another classification algorithm. So please, this is opposite of k nearest neighbor. K nearest neighbor algorithm or classification algorithm is the easiest and simplest classification algorithm. But at the same time, the logistic regression will involve a lot of mathematics. Good evening, Panto. Okay. So we'll try to understand, or we'll try to derive each one of them. Okay, so this brief introduction of myself. My name is Vishal Rawatiya. I have 10 plus years of teaching experience. Following are the achievements and areas of expertise. Okay. This is my Telegram group. You guys can join this Telegram group. If you have any doubt related to GATE preparation, whether it is CS paper or DA paper, you can ask me. Okay, so these are the announcement. On the 8th of October, BYJU'S exam prep is going to conduct a national scholarship test for GATE exam. You can participate in this scholarship test, and based on your performance, you may avail up to 90% off on all our programs. Apart from that, same on the BYJU'S exam prep app, Abhinav Negi sir is going to conduct a workshop on 11th of October at 7:30 p.m. In that particular workshop, sir is going to discuss that is it possible to cover the GATE 2024 syllabus timely if you are running behind, right? So if you want to analyze that, or if you have any doubt related to completion of syllabus, then this workshop is for you. This scholarship test as well as this workshop can be attained on the BYJU'S exam prep app. You just need to install the app and you just need to register using mobile number. It's absolutely free and you will be able to participate in the workshop. You should also, now it's the high time that you should start appearing for the mock test. So you can choose the mock tests which are being conducted on the BYJU'S exam prep. The link for the BYJU'S exam prep app is in the description. You can download the application from the description and register using your mobile number. Okay guys, let's start. So what is logistic regression? What is logistic regression? So we have learned the concept of linear regression, whether it is simple linear regression or multilinear regression. But regression is a different concept. Here the name may be regression, but it is actually a classification algorithm. So logistic regression is a statistical model which is also known as logit model. Log is involved, therefore it is also known as logit model, often used for classification or predictive analysis. So you want to predict whether something will happen or not happen. So something will happen or not happen. Yes, Fanto, I'll do that. Something will happen or not happen. It depends on the probability of that particular thing. So logistic regression estimates the probability of an event occurring, that with what probability that particular event can occur. So logistic regression will try to estimate the probability, and based on that probability it will decide that it will occur or not occur. Okay. Now apart from that, because we are talking about the probability, your dependent variable which we are going to discuss will be bounded between 0 and 1, because probabilities are in the range of 0 and 1. Now in the probability, what will happen? We will perform a transformation. So that the probabilities, we can eventually perform the evaluation between 0 and 1. We'll see how it can be done, right? And it is related to odds. So please try to understand on what we will perform the log. So we will perform the log on the odds of the happening of an event. So please try to understand there is a basic difference between the odds and the probability. What are the odds of an event odds of an event to occur. So odds of an event to occur is that the probability, or basically the probability that the event will occur divided by probability that the event will not occur. So whereas what is the probability of an event to occur? The probability of an event to occur will be the chances of that event will occur divided by overall manner in which the event can occur. So these are the two difference between odds and probability. So that will also be taken care of in this particular scenario. Okay. So when we talk about logistic regression, then it is somewhat similar to the linear regression. Somewhat similar to the linear regression, but the only difference is that linear regression is used for the purpose of regression, whereas it is used for the purpose of classification problem. Generally, logistic regression is used for binary classification. Generally, I am talking generally. It is best suitable for binary classification, but with some modifications, this algorithm, logistic regression algorithm, can also be used for multi-class classification. So what is binary classification? There will be only two class: yes, no, true, false, 1, 0 type of scenario will be there. Yes, possible outcome divided by total outcome will be your probability, right? And odds are something that with what rate the event can occur divided by with what rate the event cannot occur. Okay. So there's the idea. Now let's start with the concept of linear regression. What do we do in the linear regression? Let's try to understand. Can we perform the classification using the linear regression? Yes, classification can be performed using linear regression, but there will be some limitations. Let's try to understand them. So please try to understand that this is your variable x and this is your outcome. Right? Please try to analyze a simple situation. So this is something like, with the easiest example is that how much efforts you put and how much result you obtain. Right? So the easiest example can be that for how many hours you study per day, and based on that, what is the outcome, whether you pass or you fail. Right? So let's assume that we start thinking that if somebody study for 3 hours daily or 4 hours, let's assume 4 hours. So just the hours studied. And this is pass or fail. Right? So we are trying to classify, therefore let's assume that pass is 1 and let's assume that fail is 0. Right? So in this axis, that is on the axis of outcome, this value is 0 and this value is, let's assume, 1. Right? So if we are assuming that if somebody study for less than 4 hours, then he will fail. This is what we have observed from the past data. This is what we have observed from the past data, that if somebody study for less than 4 hours, then he will eventually fail. But if somebody study for more than 4 hours on the daily basis, then the chances are that he will pass. Right? So 4 hours, then you may increase 5 hours, 6 hours, 7 hours, etc. Right? So can we solve this problem using linear regression? Please try to understand. How can we solve the problem using linear regression? We can eventually try to draw a line which best fit in this particular scenario. So the idea is that this is something, let's assume that this is the line which is our best fit line. There is a line which is our best fit line. What's the thing? Please try to understand. We will put the values of x. This is an equation. Let's assume that this equation is nothing but this is my equation of line, that is beta 0, that we have studied in the linear regression, that is beta 0 plus beta 1 x. So this is my best fit line. Let's assume that this is the best fit line. Now the idea is, when we pass the value of x, or that is the number of studies hour studied, number of hours studied per day, if this value comes out as more than 0.5, if this value comes out as more than 0.5, then let's assume that the student will pass. But if this value is less than 0.5, then the student will fail. So that's the logistic regression analysis. But please try to understand, we have just defined that this will eventually try to calculate the probabilities. The logistic regression will try to calculate the probabilities. So can we use this particular thing to define the probabilities? No, because for some values of x, the value of y may be more than 1, but probability can never be more than 1. The probability can never be more than 1. Therefore, that is the very first problem with this particular approach. If we use the logistic, or sorry, if we use the linear regression for the classification problem based on the probability, then ultimately it will fail, because the probability cannot go beyond 0 and cannot go cannot go beyond 1 and cannot go below 0. But here, for some values of x, the value of y may be negative, and for some values of x, the value of y may be greater than 1. Right? So that's one problem. Another problem is that this line can completely shift from its original position if there are some outliers. So this is the problem with the linear regression. If we try to classify using the concept of linear regression, then the two main problems which we will face is that the values may not be in the range, and another problem is because of outlier. So let's assume that there is someone who studies for 12 hours a day, right? So obviously he will pass. And let's assume that somebody studies for 13 hours per day. He will also pass. Now, based on this observation, if I try to draw a line, what will happen? Let's try to draw a new line. If I try to draw a new line, color. Okay. So if I try to draw a new line, then regression will somewhat shift into this particular manner. Oh, it's obviously seen. I'll have to change this. This data is too close, therefore it's the problem. Let me so the line may become like this, right? Now the idea is that the value 0.5 will be at this particular point. It means the old model will start predicting that the student will fail, because the value of y will be less than 0.5. So the old model will start predicting that the student will fail even if he study for 6 hours per day. Generally, previously in the actual model, if a student study for 4 hours or more, then he will eventually pass. What are you saying? It should be like after some point it will be 1 only. Yeah, it should be, because it's a probability concept. Therefore, after a while, the value should not go beyond 1. Right? So we will eventually try to perform some transformation on this linear regression so that the values will not go beyond 1. Right? So we will actually try to do something that after a while this value should not go beyond 1. It should be fixed at the value 1, and it should not be negative also. After a while it should remain 0. Right? That's the idea. That's what we'll try to do. And this type of curve, if you look at this curve, then let me use a different color. If you look at this curve, then this curve is somewhat similar to your S shape. Clear? So that's what we will try to obtain by performing some transformations on this particular linear equation. Clear? But the idea is there are two problems, that if there are some outliers, who perform differently rather than the normal trend, then ultimately your best fit line will shift, and because of the shift in that best fit line, the threshold will change. The threshold value will change. It may be possible, so it's almost half. So let's assume 0.3. So this value is 0.3. That is, if the value of y is greater than 0.3, then only the student will start passing in the actual database, but it will predict fail until the value reaches to value 0.5. Right? So that means up to 6, that is, if the number of hours are 6 or less than 6, then this model, this new model which is there in the presence of outlier, will eventually start predicting that the student will fail. Clear? So these are the two problems. So we want to handle these two problems so the idea is this is the most normal data. So whatever calculation happens should happen in this region only. Whatever calculation happens should happen in this region only. After that, whatever happens, the value should be 1. Value should be 1. And the most general trend should be reflected at the central point. Clear? So anyway, we are assuming the general assumption while considering the logistic regression is that there should not be outliers, because the outliers can affect the model tremendously. It should be like after some point it will be 1 only. Okay. So please, this is the linear regression. So linear regression will eventually fail in two cases. What? First, in presence of outliers. And second, that the values may be outside the range, or the dependent variable or the estimated value may be outside the range. The range is between 0 and 1. So please try to understand, this is your function y. This is the predicted value of y. How do we predict? Let's assume that this is y. So y equals to 1 means pass, y equals to 0 means fail. So this is the value of y. Now we want to do something so that the value of y never goes beyond, the value of x never goes, value of y never goes beyond 0 and 1, means it remains between 0 and 1. So please try to understand this concept. Please. A transformation is performed so that range of predicted value remains between 0 and 1. So please try to understand one simple concept. Sir, what we want to do, we want to do something so that after a while, after a particular point of time, this value should not go beyond 1. How can we do that? Using this same linear equation, we are trying to squash this line only, but how can we do that? Right? So the transform, so please try to understand. If I say that P is the probability that the person will pass or the student will pass, and if I say this 1 minus P is the probability that person will fail, so this is known as odds. So if the odds are more than 1, or if the value of odds is more than 1, that is the value of P is more than the value of 1 minus P, then the student will pass. If the value of odds is less than 1, that means the value of 1 minus P is higher than the value of P. That means the probability that the student will fail is higher than the probability that the student will pass. Then this odds will eventually say that the odds are that the student will fail. So if the value of odds is less than 1, then the event will not occur. If the value of odds are more than 1, then the event will occur. Clear? So this is the simple concept which we define as odds, right? But what actually, how do we actually perform a transformation so that we get the value of probability? So please try to understand. We define the value of probability as what? I'll explain that how that equation is derived, but the value of probability is defined as 1 upon, please look at this, 1 upon 1 plus e raised power minus of, what is the equation of line? So the equation of line is beta 0 plus beta 1 x. Beta 0 plus beta 1 plus x. Right? Now tell me, whatever this value is, whether it is positive or negative, whether this value is positive or negative, you know that the value of e raised power something will always be positive. The value of e raised power something will always be positive. So if this value is 0, then e raised power 0 will become 1. If this beta 0 plus beta x value is a positive, look at this. Look at this. Let me represent that if this value, there are three possible values, that if this value is 1, that is actually equals to e raised power 0. If this value is 1, that is e raised power 0, that means the value of beta 0 plus beta 1x is actually equals to 0. Then it implies the probability will be what? 1 upon 1 plus 1 will be 0.5. 1 upon 1 plus 1 will be 0.5. Now, if this value, which you are talking about, if this value is less than 1, if this value is less than 1, so when exactly this will be less than 1? When beta 0 plus beta 1 x, this value will be less than 1 when beta 0 plus beta 1 x will be greater than 0. So when it is greater than 0, then it will be e raised power minus something. E raised power minus something means 1 upon e raised power something. 1 upon e raised power something. When you say 1 upon e raised power something, this value will be greater than 1 or less than 1? This overall thing will be less than 1 or greater than 1? So this overall thing will be less than 1. So if this value becomes less than 1, if this value becomes less than 1, if this value becomes less than 1, then ultimately it will be 1 plus some value which is less than 1. So the denominator will be less than 2. The denominator will be less than 2. In that scenario, the probability, or let me write somewhere else, I guess the camera is there. So in this scenario, the probability will be what? So in this scenario, the probability is that the probability value will be greater than 0.5. Yes or no? Because the denominator is less than 2. 1 upon something less than 2. 1 upon something which is less than 2 will be 0.5. Now the problem, third thing. So if this value is negative, or if this value is greater than 1, so when exactly this value will become greater than 1? So this value will become greater than 1 when this power of e is a positive number, that is beta 0 plus beta 1 x is negative. Beta 0 plus beta 1 x is negative. So beta 0 plus beta 1 x is negative, then it will implies that the denominator will be 1 plus some value which is greater than 1. Some value which is greater than 1, because if this value is a positive or if this value is negative, then this e raised power some positive value, e raised power some positive value will be greater than 1. E raised power some positive value will be greater than 1. So the denominator will become greater than 2. If the denominator becomes greater than 2, then it actually says the probability will become less than 0.5. Is these three things are clear? These three things are clear, that if I define the probability of an event to occur like in this particular manner, if I define the probability of an event or probability of a student getting passed, if I define the probability of a student getting passed, P is the probability of a student getting passed in this particular manner, then do you understand that the value, when the value of beta 0 plus beta 1 x is greater than or equals to 0, value of beta 0 plus beta 1 x is x, here it is x, is greater than or equals to 0, then the probability will be greater than 0.5. If the value of beta 1 plus beta 1 x is less than 0, then the probability will be less than 0.5. Clear? So if I plot this, and you know that the value, you know that this value will never be negative, because 1 upon whatever positive value, this term is always going to remain positive. This will be the maximum value will be when it is infinite, when beta 0 plus beta 1 x tends to infinite. When beta 0 plus beta 1 x tends to infinite, this probability will start tending to 1. When this beta 0 plus beta 1 x tends to minus infinite, then this value will eventually become 1. Minus infinite. So this value will become 0. This value will tend towards 0. Clear? Sir, fail is what are you asking, sir? Fail is, I did not say fail. What are you asking, Fanto? Fail is what? This is the probability of a student getting passed. This is the probability of a student getting passed. We always define, when it is a binary classification, we think in terms of 0 and 1. So that the probability that the value will be equals to y. Probability that the value will be equals to y is given using this. I mean total outcome. These are not the total outcome. Please, these are not the total outcome. These are not the total outcome. You can actually analyze that if these are the total outcome, then this one will eventually become the probability. This one will eventually become the event, the chances of event to occur. That is the possible ways in which the event can occur. But you know that the possible ways in which the event can occur are many. The possible inputs in which the event can occur, that is possible ways in which the student can pass, are many. There is not only one single way in which the student can pass, right? No, denominator is nothing. Denominator is nothing. You just need to think in terms. So I'm telling you that this is what we are supposed to get. Please try to understand. The only thing I'm asking is that let's assume that the probability of a student getting passed, let's assume that the probability of a student getting passed is defined using this particular expression. If I define the probability of a student getting passed using this particular expression, then what will it say? So the value of P will always be between 0 and 1. This value will always remain between 0 and 1. This value will always remain between 0 and 1. Now, whenever the value of beta 0 plus beta 1 x is greater than or equals to 0, the probability will become 0.5 and hence greater or equals to 0.5. So in those particular cases, 1 minus P will become less than 0.5. 1 minus P will become less than 0.5. Therefore, the odds that the student will pass will increase, will be high on the higher side. Now, if the value of P is less than 0.5, so it will happen when the beta 0 plus beta 1x is less than 0. When the beta 0 plus beta 1x is less than 0, in that case, the probability will become less than 0.5. So when the numerator is less than 0.5 and the denominator is greater than 0.5, then the odds will become less than 1. So if the odds are less than 1, then the chances that the student will pass are less. Clear? Clear? So this is something we are actually defining. That this odds, what will be the range of this odds? So the odds that student will pass divided by the student will fail. You can actually define this odds in terms of, So let's assume that the odd is represented, that the student will pass or fail is represented using this particular thing, right? So another problem here is that we actually want to represent the value. This value will remain between 0 and 1. This value will remain between 0 and 1. Sorry. Why 0 and 1? This value will vary from 0 to infinity. This value can vary from 0 to infinity. Yes or no? The odds can vary from 0 to infinity. Not exactly 0, not exactly infinity. I understand all the possibility of, yeah, but I won't be able to get, have you taken what? P as, yeah, that's what I'm trying to define, right? I have just explained you one simple thing that, okay, this is how we will define the probability, but how actually we will get this term is, that's what we are trying to understand. So I have defined the final outcome before explaining that how that outcome is achieved, so that you will have in your mind that what we are trying to obtain from here. What we are trying to obtain from here, that's what I have defined before actually deriving that particular thing, because we know that we want something which is like probability, that is the value that will vary between 0 and 1. The value that will vary between 0 and 1. Clear? So now let's try to understand that these are the odds, and the odds, the range of the odds will be between 0 to infinite. The range of the odds will be between 0 to infinite. Now look at this line. Now look at this line. So this value, whatever this value is, the values of x are from 0 to infinite. The values of x are from 0 to infinite, and apart from that, we don't want this value of y to be less than 0. We don't want this value of y to be less than 0. So what you need to understand is, sir, we are actually defining that let's assume that the probability that the student will pass, is a function of e raised power beta 0 plus beta 1x. If I think of it like this, right? Now, please try to understand. If I define it like this, then what will be p upon 1 minus p? Sir, p upon 1 minus p will be what? P upon 1 minus p. Sorry. I've taken the wrong value. Sorry, guys. So let's assume that if I define the log for this, please try to understand that why log is taken, because we want to reach to a situation where the range is between 0 to infinity. So the log is defined in the range 0 to infinity. The log is defined in the range 0 to infinity, then probability will be 2. Probability will not be 2. Right? So log is defined for range between 0 to infinity. So if I define the log of this particular function, that is 1 minus p. So in range 0 to infinity, in the range 0 to infinity, the value of log will vary from minus infinity to infinity. The value of log will vary from minus infinity to infinity, and that value is actually represented using this particular function. That is, the value is represented using beta 0 plus beta 1x. Whatever is being defined by this odd is actually representing beta 0 plus beta 1x. So this thing is nothing but beta 0 plus beta 1x. That's what we are trying to define, that rather than thinking in the simple linear equation, rather than thinking in terms of, P equals to E something. No, that's what I said. Fanto, look at this. Not P. P is not E raised power something. This is the correct equation. I just wrote E, but log of the odds will be a range which will be the range of this particular function will be minus infinity to infinity, yes or no? Please look at this particular concept, that why this transformation technique is used. Because the value of this equation, or the values of beta 0 plus beta 1x, can be anything between minus infinity to infinity. For different values of x, the value of beta 0 plus beta 1 can be anything between minus infinity and infinity. Now the same equation beta 0 plus beta 1 x should be used to define the probability. The same equation beta 0 plus beta 1 x should be used to define the probability that the student will pass or student will fail. Right? So let's assume that P is the probability that the student will pass, 1 minus P is the probability that the student will fail. Therefore, the odds that the student odds of a student getting passed will be given by P upon 1 minus P. Right? If I define it like this, then the odds will vary between 0 to infinity. Right? But we need a value which is between minus infinity to infinity. So if I perform the log of this particular thing, then this value will vary between minus infinity to infinity, yes or no? This value will vary between minus infinity to infinity. So we are just trying to obtain the relationship between this linear equation, which will vary from minus infinity to infinity, and the probability term which will vary between 0 and 1, and the probability term which will vary between 0 and 1. Are you getting this? Everybody, the value of beta 0 plus beta 1x will be in the range minus infinity to infinity. We want to translate it into the probability, and the probability will vary between 0 and 1. So if I define the odds that the student will pass is the chances of the probability that the student will pass divided by probability that the student will fail. This range will be, this value will be in the range 0 to infinity, right? If I perform the log of this odds, then this log of the range of this log of the odds will also be between minus infinity to infinity. So if I can somehow transform this range of minus infinity to infinity into this particular range, and I can solve the equation for P, then I'll get the term probability in terms of beta 0 and beta 1. I'll get the probability in terms of beta 0 and beta 1. Got the idea? So that's the logic that we will eventually use, that the log of odds. This is known as log of odds. You can actually see. I just defined. So a logic transformation is applied on the odds. That is the probability of success divided by probability of failure. That is the student will pass divided by the student will fail. Right? So this is used because it is simple to convert. So please try to understand the logic of the probability that the student will pass divided by the probability the student will fail. This transformation technique is used to represent beta 0 plus beta 1x. Now at this point of time, if I take the exponential, so how, if log goes this side, what will it become? So it will become exponential. So p upon 1 minus p will become what? P upon 1 minus p will become e raised power beta 0 plus beta 1x. Yes or no? I can write it like this. P upon 1 minus p is e raised power beta 0 plus beta 1x. Same transformation. This is the range. The range is satisfied, and we are just trying to obtain the value of p in terms of beta 0 and beta 1, so that the beta 0 plus beta 1x equation can be squashed in the range 0 and 1. Clear? So from here, let's try to solve this. It will become p equals to e raised power beta 0 plus beta 1x minus p times e raised power beta 0 plus beta 1x. If this goes this side, then it will become p will come this side, it will become 1 plus e raised power beta 0 plus beta 1x. This will become equal to e raised power beta 0 plus beta 1x. So from here, I can define the value of p as e raised power beta 0 plus beta 1x divided by 1 plus e raised power beta 0 plus beta 1x. Is it the value of the probability? If this is the equation, if this is the logic transformation to convert the equation beta 0 plus beta 1x in the range 0 to 1, that is, if it is the function to squash this linear equation beta 0 plus beta 1x into the range 0 and 1, then I can use this particular function. So it will define the probability. This probability will be between 0 and 1. This probability will be between 0 and 1. So this particular function will be squashed between 0 and 1. Yes? Clear? Now please try to understand. Please try to understand. If I divide the numerator and denominator by e raised power, divide numerator and denominator, please try to understand. I was not supposed to derive it, but that's okay. So I'll have to skip some of the topics because otherwise the session will become too lengthy. So we'll do some other time, don't worry. We'll do some other time. Let's try to understand as much as we can understand. Right? So divide numerator and denominator by e raised power beta 0 plus beta 1x. Right? So what will it become? Therefore, what will be p? So it will be, this will become 1. This will become 1 upon e raised power beta 0 plus beta 1x, and this thing will become 1. So I can rewrite it as 1 upon this 1 goes left hand side 1. So e raised power this can be written in the minus power, minus of beta 0 plus beta 1 x. Got the idea why this probability function is used? Why this probability function is used in the logistic regression? Clear? Why this function is used? Because this function will squash your linear line into the range 0 and 1. Into the line 0 and 1. Clear? Okay. Let's for the simplicity purpose, let's assume that z is being used to represent e raised power, or z is being used to represent beta 0 plus beta 1 x. Let's say let this is something, let z is beta 0 plus beta 1 x, right? So now if I try to define this probability, this is the probability and this probability is, so probability can be defined in the terms of z. So I write that probability will be can be seen as a function of 1 upon 1 plus e raised power minus z. I can write it like this, because it will become difficult to express this particular expression in the form of a line. So let's assume that we are plotting the curve for p with respect to value of z. We are plotting the curve between p and z. So please try to understand. Can you please tell me that what will be the nature of this curve? Can you please tell me what will be the nature of this curve? Please try to understand. The value will range between 0 and 1. The value will range between 0 and 1. So the probability value will range between 0 and 1. But on it. This is your line 0. This is your line 1. So basically, this is nothing but your z. This is nothing but your z, and this is your probability. This is nothing but z, and this is your probability. Sir, can it help in electrical engineering? Student 5, this course is especially for DA students who are preparing for DA paper. This course is for students who are preparing for DA paper, right? So if you are appearing for the DA paper, then this can be useful for you, otherwise not, right? So please try to understand, this value is 0 for probability, this value is 1 for probability. So the range of probability will be between 0 and 1. So please tell me, what will be the probability if z is equals to 0? What will be the probability if z is equals to 0? So this point is 0, 0. So at this point, z is 0 as well as, at this point, z is 0 as well as p is 0. Clear? So at z equals to 0, what is the probability? Sir, at z equals to 0, the probability is 0.5. 1 upon 1 plus e raised power 0 will be 1. 1 upon 2, this is 0.5. Got the idea? And I have already defined that when the value of z, this is your z, this is your z, when the value of z is negative, the probability will be less than 0.5. When the value of z is negative, then the probability will be less than 0.5. And the value of z is greater than 0, then the probability will be greater than 0.5. Done. On applying this logic transformation, why do we call it logic transformation? Because we were taking the logs of the odds. We were taking the logs of the odds to transform this linear equation or to squash this linear equation in the range 0 and 1. Clear? We are able to squash this between the range 0 and 1. Now, that's the idea. Whenever the probability will be, if P is greater than 0.5, then, sorry, 0.5. Now, it will be used in a particular manner that whenever the probability is greater than 0.5, then Y, which is your output, this is your output Y, right? That is, student will pass. Then Y is equals to 1. What does it mean? That is, student will pass. If the outcome on this value, if P is less than 0.5, then Y equals to 0. That means the student will fail. So that's what we are trying to model now. Now what will happen? Whatever the original points are available, whatever the original observations are available in the training data set, with respect to those training data set, we will adjust the values of B0 and B1. We will try to adjust the values of B0 and B1 such that these conditions are satisfied. Means we will try to adjust the value of B0 and B1 so that when the student passes, then the value of beta 0 plus beta 1 x will shift. Because of beta 0 we can shift the equation. So then the value of beta 0 plus beta 1 x will be greater than 0, and when the value greater than or equals to 0, and when the value of beta 0 plus beta 1 x will be less than 0, then it will correspond to fail. Clear? We will adjust the parameters beta 0 and beta 1 such that this particular condition is satisfied. Getting the idea? Clear? Tell me. So guys, I was actually supposed to discuss the other types of things also related to logistic regression, but you guys were not ready to understand this mathematics itself, therefore it took a little bit longer. Now whatever I need to discuss is, I was assuming that you know some concepts related to this particular transformation, but if you don't know this concept, then what I am going to discuss ahead, that is the cost function for the logistic regression and the gradient function. I will have to define the gradient. Please try to understand this equation which you see here, if you plot it, then the gradient of this will not be a convex function. What does it mean? If you try to plot this with the different values of x, then you know beta 0 and beta 1, then its gradient will eventually look something like this, right? So what do we do? Sir, in the gradient, that means if with respect to this particular function, if I take the y predicted minus y actual, if you perform the square of this, then in the original cost function, which we define y minus summation of y minus y original minus y predicted square. That's what we do. Summation of y predicted minus y actual square. But here, when I take this to predict the value of y, and if I perform the square of this, then its gradient function will look something like this, because it's not a perfect square function, it's not a convex function. So gradient generally, when the equation is y minus beta 0 plus beta 1 x whole square, when this is the function, then with respect to x, this will be a simple parabolic function, that will be a convex function. So when we try to partially derivate it with respect to beta 0 and beta 1, there is a unique minima, which is your global minima. Yes or no? If there is only one minima in the function, then it will be the global minima. If there is only one minima in the function, then it will be the global minima. But here, because this function is not a linear function, when I try to draw it with respect to beta 0, beta 1, then it will have multiple local minima along with a global minima. Multiple local minima along with the global minima. When I try to converge this, then I will reach to a point where the slope is equals to 0. But in this particular case, when there are multiple global minima, when there are multiple local minima, it may be possible that when I try to differentiate it, this value becomes 0. And once it becomes 0, it will not optimize further, because it only tries to optimize up to a level where the slope becomes 0, that is, the losses become 0. Once the loss becomes 0, it will not try to analyze it, it will not try to modify it further, it will not try to model it further for the more accuracy, but ultimately this will be the wrong cost function. Why? Because this is not the global minima, this is the local minima. The actual minimization will be with respect to this local minima. Got the idea? The actual minimization will be with respect to this global minima. That overall cost is minimized, then only your loss function will be minimized. Here the loss function will be convex function. Therefore, if we try to obtain the gradient descent for that, then ultimately you will eventually reach to the global minima. But in this case, it is not guaranteed that you will reach to the global minima. You can stuck at any local minima. You can get stuck at any local minima. Try to analyze. What you can do is, you can eventually try searching the convex function and concave function. You can eventually search for the graph of 1 upon e raised power 1 plus e raised power minus x. You can eventually search for the graph of 1 upon 1 plus e raised power minus x. If I try to use the concept, of minimum or the minimization of sum of squared error, if I try to minimize the sum of squared error, then the sum of squared error will result a gradient descent of this particular type, and it cannot be minimized to the we don't know whether when we are trying to minimize it, it is the global minima or local minima. Therefore, in order to solve this problem of global minima and local minima, we'll have to define a new cost function for the logistic regression. By analyzing this particular sigmoid function. Sir, what do we call it? This function is called as sigmoid function. Clear? So why do we use sigmoid function? Because it gives the values between 0 and 1. Whenever so we'll set the threshold as 0.5. When the predicted value is above this threshold, then we will classify it as y equals to 1. When the threshold value is less than 0.5, we will classify it as y equals to 0. Clear? Clear at this point of time? This is clear. We'll try to modify it further in the upcoming session, but nothing can be done as of now, because the time is already 11:10 and we will require. So these slides were actually available for some other reason, but we got involved in the derivation of this equation. Anyway, don't worry. See, it's in my hand. So we have understood the basic concept. So I'll just, in the next class of logistic revision part 2, we'll conduct another session, that is logistic revision part 2. In that particular session, I will just give you the initial explanation of this particular logit transformation, and then we'll start discussing the concept of cost function and the minimization of loss function. Clear? So those are the two things which are yet to be seen, but anyway, that we'll discuss in the next session because the time is not sufficient. Clear? So this is it. This is my Telegram group. You guys can join. Thank you very much for joining this session. If you liked the video, then please hit the like button. If you are new to the channel, then subscribe for the channel and press the bell icon so that you can get the notification about our upcoming video. That will be all. Thank you very much for joining the session. Thank you very much for joining the BYJU'S exam prep app. Thank you very much.